In this last video, I want to talk about errors. And when we have errors in our hypothesis testing or our significant test, I want you to think of, especially go back to the court case. Let's start with our court case, and we understand that in a court case, we know that our null hypothesis or H naught is that the person is innocent. And then HA, the alternative is that they are guilty. So what ends up happening in a court case is they go through everything, they provide all the evidence, and at the very end of the court case, they make a decision, which is the person is innocent or guilty, and then they say the evidence supports or does not support that. Well, it's often the case that when we have court cases like this, we get things wrong, and we commit these errors. And the same thing that happens in a court case is the same thing that happens in real life, where errors can occur, where the evidence suggests one thing, but really what happened isn't what the evidence is suggesting. And so we give our errors and hypothesis testing special names. The first error is called a type 1 error. And a type 1 error occurs when you reject here's the key thing, you reject a true null hypothesis. So if you reject a true null, you commit what is known as a type 1 error. And with respect to the court case, here's what that means. This null right here is true. That means that the person is really innocent. All right? And what ends up happening is we reject their innocence. If I reject your innocence and you are really innocent, then what have I done? Well, if I reject your innocence, I'm saying you're guilty. But we know that you're innocent. You're really innocent. So I'm saying an innocent person is guilty, or what you're really doing is you're locking up an innocent person. That's what a type 1 error is. It's rejecting a true null. So that means that in order to do that, this null has to be true. If you reject it, you've committed a type 1 error, which means you made an error. In a type 1 error for us, and the nice thing about a type 1 error is that we give it a special name. And that type 1 error is actually this alpha, or the level of significance that we set earlier. So when you're setting that 5% significance level, what you're saying is that I'm okay with locking up an innocent person 5% of the time. If it means I'm going to let a certain amount of guilty people get convicted when they're supposed to, and a certain amount of innocent people also walk when they're supposed to. But I'm okay with locking up an innocent person 5% of the time. The question is, are you okay with that? Well, if you're not okay with that, let's say you don't want to lock up an innocent person 5% of the time. The good news is you can move alpha up and down however you see fit. Let's say instead of locking an innocent person up 5% of the time, I want to lock an innocent person up 1% of the time. Well, here's what happens then. If I'm locking up an innocent person only 1% of the time, naturally that means I have to let more people walk. And so what is that? So that affects this now. If more people are walking, that means we also have a chance to let more guilty people walk. When we let guilty people walk, that's called a type 2 error. And a type 2 error is when we fail to reject a false, this should be the word null here, a false null hypothesis. We commit what is known as a type 2 error. And again, that would be a false null. We'll come back up here again. If a null is false, remember in the court case, your null is that the person is innocent. If that null is really false, it means that this person is really guilty. But you fail to reject their innocence. That's what you're doing. You're failing to reject the fact that they're innocent. So if you fail to reject their innocence, which means you're saying they're still innocent, but we know they're really guilty. Well, that means that this null was false. But instead of rejecting it like you should have, you failed to do that. You've committed a type 2 error. So this is letting a guilty person walk. And a type 2 error is known as beta. What I want you to understand is that they're inversely related. The errors are inversely related. If I want to lock up less innocent people, I have to let more guilty people walk. Likewise, if I don't want to let more guilty people walk, I'm gonna have to lock up more people in general. If I'm locking up more people in general, then I'm also gonna lock up more innocent people. So what this is basically saying here is that these errors are inversely related. If you want to decrease the amount of innocent people you lock up alpha, you're going to have to increase the amount of guilty people you let walk beta. Likewise, if you want to increase, or if you want to, let's write it like this, if you want to decrease the amount of guilty people you let walk, then you're going to have to increase the amount of innocent people you're actually locking up. These errors are inversely related. So as one goes up, the other one goes down. And the question becomes, well, which one is the worst error? Is letting more guilty people walk a worse error if it means we lock up less innocent people? Or should we lock up more innocent people if it means we're going to catch more guilty people? And that's a question we have to decide. It's a tough question to answer. But coming over here, this is called a decision matrix. And you can use it to help you to keep your errors in check. And here's what this says. Over here is the actual decision. You're either going to reject H naught, or fail to reject H naught. And here's what's going to happen. Either H naught is really going to be true or H naught is really false. If we reject H naught and H naught is true, if I reject your innocence, I'm saying you're guilty, but really you are innocent, this is an error. This right here is a error. As a matter of fact, you've rejected a true null. This is the error alpha. It's a type 1 error. If I reject your innocence and the null is false, which means that I'm rejecting your innocence, which means I'm saying you're guilty, and the null was false, which means you really did commit the crime, then this is a correct decision. If you fail to reject my innocence, which means I'm still innocent, and my null is true, which means that I really am innocent, so I'm still innocent, I really am innocent, this is also a correct decision. So this case over here is locking up a guilty person. This case right here is letting an innocent man walk, which are both correct decisions. The last case, though, if you fail to reject my innocence, which means I'm still innocent, but my null is false, which means that innocent null that I have is now false, which means I'm really guilty. So now here's what happens. You're saying I'm innocent, but I'm really guilty. This is a error. And it's beta, or the type 2 error, because you're letting a guilty person walk. So this is what we call a decision matrix. And in this decision matrix, we see that you have 2 errors and 2 correct decisions. So let's talk about how errors are affected and what they do in terms of a real-life problem. Let's look at the example. It says, identify the type 1 and type 2 error for each scenario. Give the consequences of each, which one is more serious. The USDA limit for salmonella contamination for chicken is 20%. A meat inspector reports that the chicken produced by a company exceeds the USDA limit. You perform a hypothesis test to determine whether the meat inspector's claim is true. So the claim is that it exceeds it. So let's start off by first off saying that it doesn't, which means that mu is equal to 0.2. If it's 0.2 or less, this means that the meat itself is safe to eat. Now, the claim being made by the meat inspector is that mu exceeds that, so it's greater than 0.2, which means that this is unsafe. And notice how I'm writing this in terms of words because the words are going to help me understand the errors here. And when I do this, the first thing I'm going to say to myself is, let's talk about what are the errors going to be. The first error would be a type 1 error, which means I have a true null. True null means that the meat is really safe. So in a type 1, the meat is really safe. The null is true. But the test is going to reject this. But the test rejects and says the meat is unsafe. The question is now, what is the consequence of this? The meat is really safe, but the test says it's unsafe. Well, what do you do to that meat? You throw it out. Why are you throwing it out? Because the test said it was unsafe. Well, what did you just throw out though? You threw away good meat. So the consequence is you're throwing away good meat. Well, if a company throws away good meat, what ends up happening to that company? They lose profit. And generally speaking, a type 1 error is called the producer's risk. Because the person that the company or people or whatever corporation that's producing is taking on all the risk. If you make a type 1 error, you will lose profit. The company will lose profit. In a type 2 error, a type 2 error says that the null is really false. So that means that a false null would be that the meat is really unsafe. The meat is really unsafe. But the test actually this time fails to reject. Which means that it says the meat is safe. But what happens there? The meat is really unsafe. But when we run our test says the meat is safe. So we put this meat on the shelf and people start buying it, they eat it, they get salmonella poison, they start dying. Right? Who takes on the risk now? Well, the consumer takes on the risk. And this is a type 2 error, beta. A type 2 error is known as the consumer's risk. And this is when you find out a lot in public about things, such as, for instance, with Bluebell ice cream. Bluebell ice cream committed a type 2 error in their hypothesis testing. They said their ice cream was safe to eat. And they did a hypothesis test where the null was that the ice cream was safe versus the alternative, the ice cream was unsafe. When they did their hypothesis test, they failed to reject their null. They should have rejected the null and said the ice cream was unsafe. But they didn't. They said the ice cream was safe and put it on the shelves. But what ended up happening? People started eating the ice cream and got sick. Same thing in this problem right here. People are eating the meat and they're going to get sick because it's bad meat. But the test is saying it's good meat. So this is what we call a type 2 error. And errors overall will always occur. And this is the exact reason why in a test we either reject or we use the terminology fail to reject. And when we say we fail to reject, what that really means is that we are not saying the person did not commit the crime. Our evidence just suggests they didn't commit the crime. We can't be sure that they didn't. That's why we can't accept. So we never use the words accept. I'm never going to accept your innocence, A, because your innocence is already established, but B, because these errors occur. And the errors are what can't let me accept it. I can fail to reject, which gives me wiggle room there.